Just to give you a quick introduction to our company, we are a manufacturing consultancy company and founded in 2012. We are 50 employees and we have a few offices on Birmingham, Glasgow, and London. So our main, we work principally in three main areas, which are participating on leading collaborative research and development projects. We do as well bespoke engineering services, and we also do a lot of strategic manufacturing consultancy projects. Our main area of expertise are shown in this slide. So it's about manufacturing strategy, lean and automation, advanced simulation, digital tools, circular economy, and supply chain. And I am in the lean and automation team, and this is where we do our work around collaborative robotics. So just digging into the subject now. You might be familiar with human and robot collaboration. So actually, an operator and a robot have complementary skills. So where a human operator as a human has like natural skills such as dexterity, problem solving, it can get the operator can get tired. Unlike a robot that can do very dangerous task repetitively without feeling any fatigue. But traditionally, a robot doesn't have this intelligence unless we add artificial intelligence layout on top of it. So human and robot collaboration is very interesting because of this complementarity. And usually it's implemented when an operator and a robot have to share a workspace and or a task. And in the automotive industry, I speak about here on the presentation, I focus on automotive industry because this is where our experience is. So in automotive industry, it gives maximum value for ergonomics improvement, quality improvement. We can use a collaborative robot as a third hand as well. It's also very helpful in line balancing activities, and because collaborative robots are smaller than traditional robots, there's a better floor space utilization, and it can be used for versatile and flexible operations. The key applications in the automotive industry are screwing, loading, handling, assembly, gluing, inspection. But because a workspace is shared between an operator and a robot, and there is no fence if it's truly collaborative, we need to be very cautious, and this leads as well to some of the limitations. As we know, a collaborative robot is limited in terms of payload, so a collaborative robot can handle very heavy parts, and it works at low speed because of the proximity that it has to the operator. So sometimes it's kind of challenging to meet the cycle time. Just to give you an example, in the automotive industry, the cycle times are on average about less than a minute for the operations. And then the level of risk is quite important as well because of the unpredictability behavior of the operator as a human. We need to be very cautious on how either the workspace or the task is shared between the cobot and the operator. So all of this will lead to a limited type of application that we can use that for. And yeah, so the shared workspace solves some specific problem in the automotive industry. So here I just want to present you the work that we have been doing around collaborative robots. So a few years ago, we initiated a working group with automotive manufacturing companies. Our main partner were Ford, Jaguar Land Rover, and Nissan. This working group was mainly to understand why collaborative application at this time were not very common in in the automotive industry, unlike in Europe or in the rest of the world. And then we were really motivated in facilitating a safe, consistent, and cost-effective deployment of collaborative robot system in the UK automotive plants. And then we aim to develop and share best practices related to safe applications. The main outcome of this work was the report that we published on our website. And the aim of this report was to provide a definition of truly collaborative application. It can sound very simple, but sometimes there is a confusion because we can see that in some plants, cobots are, people say that they are using cobots, but they are not using cobots as collaborative robots, but they are using that because they are small and cheap robots. And then the other aim of this report was to understand all the legal requirements around the safety of implementing collaborative applications, and then the technical specifications as well, and then develop an implementation guidelines for truly collaborative applications, along with guidance for risk assessment. We also led the RACE project, which stands for Risk Assessment for Collaborative Work Environment. And the objective, again, was quite similar to the working group. The ultimate objective was to facilitate the implementation of these cobots by creating here a virtual risk assessment tool for truly collaborative applications. So basically, with the RACE tool, the main objective was to give our partner the possibility to see how the truly collaborative application will look like and how it will work before having the real collaborative work cell implemented in the shop floor. So the algorithm is represented very simply in this slide. So as an input, we have the CAD models of the workstation, the robot, and the end effector. And then by simulation, we can simulate the robot trajectory and then the operator task. And then from this simulation, we will evaluate all the potential hazard that can happen. And then we need to evaluate them according to the technical specifications, ISO 15066, and then check as well to any risk of potential collision, and then the operator's exposed body region, and if there is any trap points, just to see if this collaborative application is safe or not. So if there is any hazard identified, we go back and we work on the simulation to make the application as safe as possible until we get to the point that we can guarantee that this application is safe. And then from the RACE project, we developed this CDC service, which stands for Cobot Design and Certification. It's divided in three main work packages. The first one is the application assessment plus the return on investment calculation. So what we do first, we go to our to the plant, to the shop floor, and we observe the current workstation as it's working without the collaborative robot. And if this targeted application, basically we want to check if a cobot will suit for this type of application, because sometimes a cobot is not the best solution. So because all we want is to improve actually the manufacturing process. So the first question that we are asking ourselves is like, is a cobot will be suitable for the application? And of course, because the customer will need to know how much money he will spend, we need to calculate the ROI, so it gives the customer a good picture of what he has to spend. So we check during this work package, we check the operator task, the accessibility, the cycle time, and even the work pieces and the end effector that that are in place in this application. And then on the application design, we answer to the question how the robot cell would look like. So we provide the 2D layout and the 3D mockup of the workstation. So it gives a better picture of how it will look like. And then we check, this is where we can confirm if the operation space-wise is okay, and accessibility as well, it's okay. And then the third work package is about the virtual risk assessment and compliance. So this is where we use the RACE tool to see how the cell will operate and if it's safe enough for the operator, because we don't want to cause any harm to the operator. So we check all these robot trajectory, operator task, and hazard evaluation. We also do some offline programming. So then from all of this, the customer will have a perfect picture of what to expect by simulation of the future workstation, basically. And then we also do some physical tests to confirm 100% that this application is safe. Thank you all for listening. I think that, yeah, sorry to be that fast. I wanted to make sure that I'm respecting the time. So if you have any question, more than happy to answer.